Hey guys, this is the first video in Chapter 10, the Intro into Gas Laws. And we're just going to talk about the first few gas laws that we talked about in class, all those named guys, and then the combined gas laws at the end. Now, before we even talk about gas laws, we need to talk a little bit about gases themselves and kind of talk about what's going on with the gases. So we started with the kinetic theory of gases. Gases are small particles that move rapidly in straight lines. They're really far apart, so they have essentially no attractive forces, essentially no volume compared to the volume of the container, and have average kinetic energies that increase with temperature. Those were our kind of tenets for our kinetic theory of gases. And as we'll see in the last video, not all of them are completely true under certain conditions. Now, whenever we talk about gases in general, there are four variables that we're really concerned about, and that is pressure, temperature, volume, and amount. And so these first four gas laws compare two of the variables in a changing system. In the last one, the combined gas laws compare three changing variables, all while keeping something essentially the same. So the first one we talked about was Boyle's law. Boyle's law is defined as the volume of a fixed quantity of gas at a constant temperature is inversely proportional to the pressure. Now, what does that mean? That means as volume increases, pressure decreases, or the more easily viewed is vice versa. As pressure increases, volume decreases. Which you can kind of imagine that, right? I mean, if you take a container and you increase the pressure, and it can vary as far as volume goes. You don't add anything else. You don't change the temperature. You just increase the pressure. You're squishing that pressure in. You're squishing that container in, and so of course the volume decreases. Now, once you let off that pressure, well, volume is going to increase. Now, what that looks like mathematically, as far as Boyle's law, is P1 times V1 equals P2 V2. Now, what that means is that the pressure of the system initially multiplied by the volume initially is equal to the pressure after the change and the volume after the change. So a quick example of this is if we have a gas in a 5-liter container at 2 atmospheres, what is the new volume? The new volume when the pressure is 1 atmosphere. And we have moles, which is N, and temperature are constant. So the other of the four variables. Go back and look, we've got those four variables: pressure, volume, moles, and temperature. Just gotta make sure everything's accounted for. Alright, so we've got a 5-liter container at 2 atmospheres, and our new pressure is 1 atmosphere, and we want to know what the new volume is. Well, we don't actually have to do any math here, because if the pressure decreases by half, that means the volume has to increase by that amount, so increase by 2 times, double. So my new volume is 10 liters. Pretty straightforward. The next in our gas laws is Charles's law. The volume of a fixed amount of gas at constant pressure is directly proportional to its absolute temperature. So what does that mean? That means that as temperature increases, volume also increases, or vice versa, as long as pressure and amount remain constant. Mathematically, this looks like V1 over T1 equals V2 over T2. Okay, the volume over the temperature initially is equal to the volume over the temperature after some change. So you have something like a container, that should be a gas at 5 liters and 200 degrees Celsius is heated to 400 degrees Celsius. And what is the new volume? Well, you might be tempted to say 10 liters because temperature doubled, but temperature didn't really double. Remember, for all gas calculations, the temperature has to be in Kelvin, right? So, knowing that, we've got 5 liters initially at 473 Kelvin. And we want to know our new temperature at 673 Kelvin. So we plug this into our calculator, and we get 7.11 liters as our new volume. And again, it makes sense, right? Since they're directly proportional, as we heat something up, that volume increases, or vice versa. If we cool something down, it decreases. Or increasing the temperature, our volume has to increase, and there it is, 5 to 7. The next law is Gay-Lussac's law. Pressure and temperature are also directly proportional. So as temperature increases, if we keep it at a fixed volume, pressure also increases. This is a very an example of a pressure cooker, right? Heat our material up. Even if we just had an empty pressure cooker, and we were able to heat it up enough and keep that pressure on it, well, of course, that pressure is going to increase, because as we increase the temperature, we increase that pressure. The gas particles hit the walls of its container harder, with more energy and more often, and so that's what pressure is, force over an area. So the gas is hitting the container harder and with more energy. We're not letting it expand, keeping the volume constant, and so the pressure has to increase. Solving problems with that one looks just like Charles's law. We can solve for any of the variables present, and not too bad. If you're given the 3, you should be able to solve for the other one fairly easily. The final named law is Avogadro's law. Avogadro's law is the volume of a gas is directly related to the number of moles of a gas, which is duh, right? If we add more of a gas in, our volume is going to increase. Pretty straightforward. But it gives us the first time in this chapter where we compare moles, right? And moles was something that we've worked with before in chapter 3 and 4. And we can do all sorts of nifty things with moles. We can do mass conversions and stuff like that. So the final named law, volume over moles, initially, is volume over moles after a change. And so if we have, say 34 grams of methane in a 5-liter container. I don't know why I like 5 liters for this video, but that's all right. 5-liter container. How many moles of methane must be added to increase the volume to 12.5 liters? Okay, so there's a couple things that we have to do here. We've got 34 grams of methane. The molar mass of methane is 16.0 grams per mole. So we have to convert this guy to moles first. So we take 34 divided by 16, and we get 2.125 moles is what we start with. Now we can plug in and solve for the new amount of moles, okay? And actually we can even change this to how many grams of methane must be added in order to increase the volume to 12.5 liters. So once we have moles, we can plug this into our equation. 5 over 2.125. We want 12.5 liters at the end, and get x there. So we can plug that in and solve. Whenever we plug that in and solve the problem, we get 5.31 as our number of moles. 5.31 moles. Or, converting back to grams, we get 85.0 grams of methane. Now the question is, how much must be added? Well, the difference between 85 and 34 is 51. So we have to add 51 grams of methane. Just an example of one of the more difficult problems you can get from that little equation there. Finally, we get to the combined gas law, where we take all the different laws that we've just talked about and put them into a combined law that the only thing that remains constant is the number of moles. And so we've got P1 multiplied by V1 over T1 equals P2 V2 over T2. And so instead of doing an example of this, what I want to talk about is when to use these problems. Notice how in all of my examples we use the same system, right? We're just changing something. We're either adding a gas, changing the volume, changing the temperature, pressure, whatever. Well, all you have to do is you have to look at what's changing and then use the law that goes with that. If I say I've got a volume and a temperature and I'm changing the temperature and I ask for the new volume, well, that's going to be Charles's law. It's the only one that we have that relates just volume and temperature. Here with the combined gas law, we've got pressure and volume and temperature. And so if I've got a problem or a system where pressure, volume, and temperature are being related and the number of moles are constant, you know that's going to have to be the combined gas law. Now, thankfully, we don't actually have to memorize any of these because, as we'll see in the next video, we'll actually be able to derive all of these guys from the ideal gas law. And we'll take a look at that next time. Well, that's it for the first video. I know it's short, but it's pretty straightforward, just talking about the four guys and then the combined gas law. Some other important things to take a look at in the notes that aren't as important as these four would be things like what a barometer is, what a manometer is, how we talk about pressure, the units of pressure. Remember, we have to know this conversion right here. 1 atmosphere is 760 millimeters of mercury, or 1 atmosphere is 760 torr. Those are the important ones there. All right, until next time, that's it for the first video in Chapter 10.